Okay, well, welcome back. If you've been following along, this is part 4. We're doing the chapter 5 review, the gateway review. We've gone through most of the review. We've got a little bit left. We're on 14 now. This review is also for Unit 3 test. So now 14. Here we go. Here we go. We're going to go back to the sketchbook. Hopefully you're following along. 14 is, we're on page 363. So 14, here we go, page 363. Let's do this. Here we go. So we have the quotient. So what we're going to be doing is we're going to be translating each of the following verbal statements into an equation, and then we're going to solve for the unknown value. X will be the unknown value. All right? So let's do this. We have the quotient of a number, and negative 15 is negative 0.7. Well, that is written like this. Let's see here. I don't like that color. It's quite dim. Let's try this one instead. That's just a little bit better, right? So we have x over negative 15 equals negative 0.17. Well, we're going to times by negative 15. So this turns into x equals negative 0.7 times 15. Negative 15. Well, right away, when we times by two numbers that are negative, we get a positive. So it's just 15 times 15 times 0.7. Well, what is 15 times 7? 15 times 7, well, first off, 5 times 7 is 35, carry the 3, so 105. But then we need to take in consideration that this is a decimal and that there's one place value after this decimal, so we need to go back one place value. So it's really 10.5. And that is the final answer. B. Oh, by the way, that was 14A. Now, let's do 14B. 14B. Let's change the color again too. Let's do a nice bright yellow, shall we? Look at that. 14B. That's nice, isn't it? All right, so it is negative 11 twelfths times a number is 2 and 1/16. So that would be written like this. Negative 11 twelfths. Oops. Twelfths x equals 2 1/16. Just like that. Well, I would make this an improper fraction. So let's make this 11 twelfths x equals, well, what is 16 times 2? I do believe that that would be 32. And so 32 plus 1 is 33, so 33 sixteenths, right? Then I'm going to times by the reciprocal, which is negative 12 elevenths, which cancels this out like so. So now it's x equals 33 sixteenths times negative 12 elevenths. Well, this is 3 times 11, so that 11 and this 11 can cancel out. And so we're left with a 3 on top. And then this is 3 times 4, right? Negative 3 times 4. And this is 4 times 4. So this 4 can cancel out, and this 4 can cancel out. So what we have on bottom is a 4, and what we have on top is this 3 and this negative 3. So and we're timesing them, so it's negative 3 times 3, which is negative 9. So x equals negative 9, and then just a 4 on bottom. And then they probably want us to change it to an improper fraction, which we will do. How many times does 4 go into 9? Well, it goes into it 2 times. 2 times 4 is 8, and then what would be left over? Well, would be 1. So this can be rewritten as negative 2 and 1/4, like so. All right, let's do C now. 14C. We're running out of time a little bit. It's getting late, so I'm going to be skipping more steps towards the end of this video. We have, according to C here, we have 1.08 is, so that is the product of a number, and 0.2. So it's written backwards to confuse you. Basically, you could rewrite this as the product of a number and 0.2. Oh, we cancel that right now. Anyway, it could be rewritten as, we could rewrite this as the product of a number and 0.2 is 1.08. Basically, this is what you're going to have. You're going to have 0.2x, right, equals 1.08. That's the product, right? 0.2x is the product of 0.2 and a number, right? And then what we want to do is we want to divide by this 0.2 on both sides so we can get x by itself. Now we have x by itself, and so when we divide, we want to change this from a decimal to a whole number, and what we do to one side, or the bottom, we do to the top, so we move this over 1 as well. Okay? So then it's just 2 into 10.8. Well, 2 goes into 10 5 times. Bring a 10 here, and we minus the 10, and we get a 0. And then we bring down this 8 here, and we bring this decimal point up. And then we ask ourselves, how many times does 2 go into 8? Well, it goes into it 4 times. And that gives us another 0. So the final answer is 5.4. All right, let's go on to the next one, which is 17. 17, here we go. It's a word problem, and it is at the bottom of page 363. It says your living room wall is 14 feet wide. You have a couch that is 6 feet, 6 1/3 feet long, that is placed against the wall. You also have 2 end tables, which are 2 1/8 feet wide on each side of the couch. All right, so let's see here. You saw a bookcase that is 2 5/6 feet wide, and you like to buy it. All right, but you are not sure if it would fit in the remaining wall space. The question is would it fit? All right, so we have a scenario here. We have a wall, right? We have a wall. Okay, and along that wall we have a couch here. Let's see here, hold on now. We're saying that from here to here is 14 feet, like so. And we say we have a couch, somewhere in the middle. And this couch is 6 1/3 feet, right? And then we have these end tables like so here, and another end table like so here, and each end table is 2 1/8 feet, right? 2 1/8. Obviously, this is not to scale. It's not a very good drawing, but this just kind of gives us a picture of what we're looking at, right? This kind of helps us understand what's going on. So basically, of that 14 feet, what we have left is whatever these. Basically, we need to minus each one of these from this 14 feet to find out how much room we have left. And then once we take the measurements of these, these pieces of furniture, and we minus them from the 14 feet, we'll know if the bookcase, which is 2 feet, 2 and 5/6 feet wide, would fit. So here we go. Let's do that. So it's 14 minus, and basically it's minus the summation of these pieces of furniture, like so. All right. So here we go. Let's add these together. So since we're adding these together, we can have 2 plus 2, that's 4, plus 6 is 10. So there's 10. Then we have 1/8 plus 1/8 plus 1/3. Well, that turns into 2/8 plus 1/3. Right? We still have that 10 over here. And then let's see here. We need a little bit more room, I think. All right. What is the common denominator? Well, I would have to say the common denominator here would be 24. No, wait a minute. Yeah, no, it is 24. So I need to times both top and bottom of this. So I get a 24 on bottom and an equivalent fraction. So that's going to be 3 on top and bottom. So that turns into 6 over 24. And this turns into 8 over 24. So then in the end I get 14 over 24. And I could reduce that, and I could reduce that by dividing by 2, so that's 7 over 12, right? So it's really 10 7/12, like so. And I'm minusing that. Remember, we started here, and now we're down here, and we're minusing all of this from that 14, right? So let's see here. We can say that we have, and by the way, you could rewrite this as, let me see here. Well, hold on now. We could rewrite this as 14 minus 10 minus 7/12. That's what we're really doing. So anyway, 14 minus 10 is 4. And then we minus 7/12 from the 4. All right. Well, 4 can be rewritten as 3, and hopefully you understand this. We've done this enough times that you should understand this. All right. It can be rewritten as that. Why? Well, what's 12 divided by 12? Well, that's 1. So what's 3 plus 1? Well, that's 4. All right. And I put 12 over 12 so I can have the same common denominator. Then I minus a 7 from that. So I have 3 and 5. 12 minus 7 is 5/12. So 3 and 5/12 is the space I have left over on that wall. And how much was that book? How much was the bookcase? How long was it? It was 2 feet. It was 2 and 5/6 feet. Well, which one's bigger? Well, this one's bigger. So this would fit within this. So yeah, we do have enough room. We might have to rearrange some furniture. I have to scoot the couch and the bookshelves over, but yeah, we'd have enough room. So that's the answer. All right, next question. Next question is 18. Your new TV costs $179.99. There was a sales tax of $14.85. What was the final price of the TV? Well, let's see here, a sales tax. That means that you're adding, all right? This is what, oh, hold on now, let's see here. It's 18, we're on 18 right here. Let's use a different color, shall we? Let's use this one. So, this is the price tag, $179.99. You're at Costco, I guess, you know, and you see this, you're like, oh, I like this TV, I want this TV. So you bring it up to the cash register, and they scan it, and then the computer does it for you, but we're going to do it for the computer now. Adds on a sales tax, and the sales tax is 14.99. no, not 90, 0.85, like so. All right, so we can set this up, vertically. 79.99, 14.85, like so. Right, simple as that. This plus this is 14, carry the 1. This plus this is 17, plus the 1 is 18, carry the 1. This plus this is 10, and then 14. Oh, and then we put the decimal here too. And then we carry the 1 again. This is 9, and then this is 1. So the final price is, that doesn't look right, does it? Final price is $194.84. That's what you pay for the TV in total. All right, let's go to the next problem. All right, the next problem is 20. So here we go, 20. No, I don't like that color. 20. There we go. 20 says a dress that usually sells for $67.95 is marked down by $10.19. Oh, what luck, right? Goodness gracious. They're being so generous, aren't they? What is the sell price of the dress? So the tag was $67.95. That's what it was. And they basically are giving you a discount of $10. So you're just going to be minusing $10.19 from this. So we just do like this, right? It's really quite simple. And then we have an 8 here, and then make that a 15. That turns into a 6. This turns into a 7. This turns into 7, and this turns into a 5. So your final price is $57.76. Voila. Next one. 21. 21. A cook making, let's see here, a cook making $1,504.75 a month has deductions of $157.32 for federal income tax, $115.11 for Social Security, and $45.12 for state income tax. What is the cook's take-home pay? Well, such is the life of people that live in America. They tax us, right? That's what they do. So this is what he was originally given. But then Uncle Sam decided that he wanted to take some money away. So the first thing he's going to be taking away is this $157, right? So let's actually rewrite this. This is what he has. He's going to be taking away $157. Let's make this bigger. Like so. So he's going to be taking away $157.32. All right, and he's also going to be taking 115.11 and 45.12. I wrote it like this so I could add them up. No, I don't need such big parentheses, right? All right. And once we find the summation of this, we're going to take this and we're going to minus it from that. So 2 plus 1 plus 2 is 5. 5, 1, I mean decimal place. 5 plus 5 is 10, plus 7 is 17. Carry the 1. 4 plus 1 is 5, plus 5 is 10, plus 1 is 11. Carry the 1, and 3. See how much Uncle Sam took? Not very nice. All right. Yeah, we don't need that negative. All right. So basically, I'm not going to rewrite things. I'm just going to put this 317 here. And since I'm done with this, I can just, cancel that out for right now because I don't need this anymore. All right, the 317 was the summation of all the deductions. So we have 5 minus 5 is 0, 7 minus 5 is 2, and then we are going to take 7 minus 7. Wait a second now. Did I do this right? Just 1 second. Oh, see, I wrote this wrong. I do apologize. It's always good to check, though. This is not a 7. That's a 4. You probably noticed that before me. That's a 4. There we go. So he makes $1,504. Okay, moving forward. All right, we cannot minus 7 from a 4, so we need to take a 1 from. Oh, we can't. That's a 0, so we can't take anything from that. So we change this into a 4. This changes into a 10, but then we need to take 1 from that 10 to move it over here to this 4. So this just basically is a 9, and then this is a 14. 14 minus 7 is 7. 9 minus 1 is 8. 4 minus 3 is 1, and then we bring down the 1. So basically what he takes home, so that was his gross, all right? If you don't know that, this is what he grossed. This is what he should have got. This is what he netted, right? He took home this. All right, next one. It's 26. Let's use a different color, shall we? It's good to change things up. So we have 26 here. All right, in 1920 there were approximately 2.9 million workers in the United States. Okay, approximately 7 out of 10 of these workers were employed in farm-related occupations. How many people had farm occupations in 1820? Well, if it's 7 out of 10, it says right here that it was approximately 7 out of 10 of these workers. So of these workers means that you're going to be timesing. So it's 2.9 million times 7 over 10. So like this. That's how you should write it. 2.9 million. So I can write like this. So that's where we're at. So what is 2.9 million times 7/10? Well, in this case, we could just time straight across. We don't need to put the million there. We don't need to add zeros to this. We'll just put 2.9, and then in the end we'll put million. Okay. So 7 times 2.9. Let's go ahead and do that. 2.9. Or write to you then 7. 7 times 9 is 63. Put a 3 here. Put a 6 here. Right? We carried the 6. This times this is 14 plus 6 is 20. And then we need to recall that this has a decimal place of 1 decimal place. So we have 1 right here. So we need to move back 1. So it's really 20.3. And then we had 10 times 1, which is just 10. So it's 20.3 divided by 10. Well, when we divide by 10, you should know this by now, but when you divide by 10, you just move the decimal place back by 1. So then the final answer is just really 2.03. And then we recall that it's million. So back in 1820, there was 2.03 million people that were in agriculture, right? Farming. All right, let's continue forward with 28. Oh, no, that's jarring. We can't have that. No. Try this one. No, we gotta stick with the darker colors. All right, 28, I think I said. Yes, 28. 28. There are 7,318 air miles between London and Honolulu. Air miles, huh? If you are a passenger on a commercial plane, what is the average speed of the plane if the trip takes approximately 11 3/4 hours? Well, we know that rate times time equals distance. All right, we've gone over this before. So we need to find the rate, but we already have the time, we already have the distance, right? So it's really 11, because this is the time, 3/4 hours, times r. All right, so we can put the r next to it, and that equals 7, 3, 1, 8. Let's change this to an improper fraction. So 4 times 11 is 44, plus 3 is 47. So 47 over 4 r equals 73/18. All right. And then what we're going to do is we're going to times by the reciprocal. So it's really 4 over 47. And we're going to cancel that out. When we do one side, we do the other side. So it's, oh goodness. So it is 7,318. All right, we can put that over 1 times 4 over 47. Well, you know what I'm going to do is, I don't know if I can reduce, I don't think, this nothing looks like, it doesn't look like this can be easily reduced. I can't factor anything out, so I'm going to time straight across. Actually, I don't know if I'll time straight across. Basically, I could rewrite this as 73/18 times 4 all over 47. And I could, instead of timesing first, I could in this case divide first if I wanted to. It doesn't really matter. Let's just time first. All right, so I don't want to confuse you. So let's do it. So it's 73/18 times 4. This is 32, carry a 3. This is a 7. This is a 12, carry a 1. This is 28, 29. So it's 29, and then we're going to divide it by 47. All right, so 47 and 2, 29,272. Does 47 to say, go into 29 or 2? No. Does it go into 292? Yeah, it does. If I round 47 to 50, and I round that 292 up to 300, then I could say that I could times by 6 possibly. So let's just try 6. I think it might work. Who knows? We'll see. 47 times 6. This times this is 42. Put 2 there, carry a 4. This times this is 24. Plus 4 is 28. So that is pretty close. So let's leave it at 6. So this turns into 282, and then this is 0, and this is 1, and then that's just 0. Then we bring down the 7. How many times does 47 go into 107? Well, I think 2 times. Let's just double check though. Pretty confident it is. That's 4, carry the 1, that's 94. Yeah, so 94. So this is 3, and this is 1. We brought down the 7 already, and now we need to bring down the 2. Oh, and of course we need to put 2 here. So we bring down the 2 here, and so now how many times does 47 go into 132? Well, maybe, just maybe. I'm going to keep bringing this down here. Just maybe it goes into it 3 times. I don't know. We'll see. So 47 times 3. This is 21. Carry the 2. This times this is 12. Plus 2 is 141. So no, it doesn't work. So I went too far down, didn't I? Up. There we go. So I'm just going to have to say it's 2 again. So we put the 94 here, and we do the subtraction. This turns into a 2, turns into 12. 12 minus 4 is 8, and then 12 minus 9 is 3, 38. Then we're going to put a decimal here and add a 0 here. All right. So when we do that, let's see, what does it say to do? It says estimate your answer and then solve the equation. It says what is the average speed? I'm going to estimate to the nearest mile per hour. But in order to do that, I need to find out what this is. So how many times does this 47 go into this right here? Well, I knew that 47 went into this right here, this 292, 6 times. So I bet about 7 times. Let's try that. So 47 times 7 is 49, and then carry the 4. This times this is 28. 28 plus 4 is 32. I bet it even goes more than that. Let's try 47 times 8. 4 times 8. This times this is 56. Carry the 5. This times this is 32. Plus 5 is 37. Yeah, that's about right. 37. There we go. And then, of course, we'll have a remainder of 4. And this is 8 here. And so I can round this up to, just leave it like that. So R equals, let's see here. Probably put like, oh, I don't like that. The squiggly mark means that it's more or less. R equals more or less 623 miles per hour, right? That's basically how fast they're going. So that's an estimate. All right. Hopefully you were able to follow all that. Again, this is a video, so if you didn't follow all of that, you got kind of lost, you can always pause and rewind to your heart's content. All right, we're almost done. We got 32 and then 33. Hallelujah, right? All right, here we go. Let's change colors again. Let's do 32. All right, we just did 28, right? Yeah, 32 is next. So we're going to go to page 366. Here's 32. We are almost done. We're at the finish line. Just one last little leg in the race. All right, 32A. Let's see here, 32A, because we're going to do all of them. So we're going to convert this 795 milligrams, right? Milligrams, and we're going to convert it to grams. All right. I'm going to teach you the way I do in chemistry, okay? This is 795 milligrams. How many grams, or how many milligrams are in a gram? So you have 1 gram. 1 gram is equal to 1,000 milligrams. That can be written as 1 gram over 1,000 milligrams. Oh, I'm sorry about that. All right. So we can take this and we can times it by this. So 795 milligrams times 1 gram over 1,000 milligrams. Now the key to this, when we're doing it like this, okay, when we do it like this, when we times by this ratio, all right, we need to remember that we want to cancel out the milligrams and be left with grams. So this is really 795 milligrams over 1. So that's up above. So we need to times by a ratio that has the milligram down below, which we've done. So now the milligram can cancel out, right? We can think of this as like x. When we have an x on top and x on bottom, we can cancel those out. And then it just basically is 795 over 1,000, you see? All right, grams, because the grams left over. And then when we have 1,000, we can move the decimal back 3 places. So it's just 0.795 grams, like so. All right, hopefully you get that. All right, next one, 32B. 32B. Here we go. 32B. We have 2.75 kilometers, all right, and we're going to convert it to meters. All right, we need to understand that there are, in 1 kilo, right? Kilometer. That equals 1,000 meters. Okay, so we could rewrite that as 1 kilometer over 1,000 meters. Okay? And again, we want to cancel out the kilometers, so we need to have a kilometer on bottom, right? Because this is really 2.75 kilometers over 1. So we need to cancel out the kilometer, and so we need to times it by 1,000 meters over 1 kilometer, like so. See that? It's the conversion ratio. So we cancel out the kilometers like this, and then what we're left with? Well, we're left with 1 and 1 on bottom, so that they don't mean anything. So we're left with 2.75 times 1,000. Well, 2.75 times 1,000, that just means that we're moving this over 3 decimal places. All right? So this turns into this. Just like so. All right. Let's do 32C. 32C. 32C, we're going to convert 25 milliliters, sorry about that. And you want to write like this, milliliters, if you're going to abbreviate it. And we're going to convert it to liters. All right, again, how many liters or how many milliliters are in a liter? Well, for 1 liter equals 1,000 milliliters. Hopefully you're getting the gist of this. It's 1 liter over 1,000 milliliters. We want to cancel this out because that's 25 milliliters over 1. We need to use this ratio right here, and we need to times this number by this ratio, and we need the milliliter to cancel out this milliliter. So it's already in the right format, right? The other one, if you recall, we switched it. We put this 1,000 on top, and this, and then it was, remember, it was meters, 1,000 meters, and then we put kilometers down below. If I do recall correctly, which that's okay. You can do that. All right, so we're going to put 1 liter here and 1,000 milliliters here. We cancel out the milliliter here, cancel out the milliliter here. So then we just have 25 over 1,000, which means that we are going to take this 25 and this decimal that's invisible here normally, we're going to move it back 1, 2, and 3 times. So it equals 0.025 liters, and that is the final answer. All right, let's do 32D. 32D is 1.05 kilograms, and we're going to convert it to grams. They're making this really easy for you. They're just using things that have 1,000 in them, meaning there's 1,000 grams in a kilogram. So 1 kilogram is over 1,000 grams. Well, this is 1.05 over 1 kilograms, right? We need to convert it to grams, so we need to times it. We're switching it. See, we want the grams on top. So it's 1,000 grams over 1 kilogram. See? We cancel out the kilograms, and then we'll just times this by 1,000. When we times it by 1,000, this decimal's moved over 1, 2, and 3, so it equals this. 1,050 grams. So there's 1,050 grams. 1,050 grams is equivalent to 1.05 kilograms. All right? All right, let's move forward to 32E. We're almost done. We got this one, then F after that, 32F, and then finally 33. and then we can take a break. All right, so 32E, we have 2.35 kilometers. All right, and we're going to convert it to millimeters. Oh goodness, this is actually more. So now we need to use two conversions. All right, and I'll show you what I'm talking about. All right, so first off, we want to convert this to meters. So a kilometer, 1 kilometer is equal to 1,000 meters. And 1 meter is equal to 1,000 millimeters. All right, those are the two conversion factors, which is true. There are 1,000 meters in a kilometer, and then there's 1,000 milliliters in a meter. Did I say liter? I'm going to say meter the whole time. And this is 2.35 kilometer meter over 1. So, actually I want to write that down a little bit farther. 2.35 kilometers over 1. So I'm going to times this by this ratio first and get rid of the kilometer. So I put 1,000 like this, meters. And then I put a kilometer underneath, like so. The kilometer is taken away, and then it's just this times 1,000. Well, we know from the ones we've done in the past that we just move the decimal 3 places. So it's 2, 3, 5, 0. It moved 3 places. 1, 2, 3, and that's a 0. Now we have that, and that's meters, right? Because the meter didn't cancel out, it's still there. So now it's that over 1, and we need to change it to milliliter. Well, we want to get rid of the meters, so we put a meter down here. And how many milliliters are in a meter? Well, that's 1,000 millimeters, like so. So we cancel out the meter here and the meter here, and then we're left with this times 1,000. So we just add 3 more zeros, or change the decimal, move it to the right 3 times. So that equals 2350, and then we move the decimal 1, 2, 3, so add 3 zeros, and that is the final answer. So 2,350,000 millimeters is equivalent to 2.35 kilometers. All right, let's do F, 32F. Let's go back down to here, 32F. Here we go. We have 0.085 liters, and we want to change it to milliliters. So it's a 0.085 liters divided by 1, and we're going to times it by now you should know that there are what? 1,000 milliliters in 1 liter. So we cancel out the liters, and then we just times this by 1,000. Well, what does that mean? We're going to move this decimal over 1, 2, 3. So it just turns into 85. So there's 85 milliliters. 85 milliliters is equivalent to 0.85 liters. All right, here we are, final one. This is the final question, and then we're done with the review. Thank goodness. Here we go. 33. The boundaries around a parcel of land measure 455 meters, 806 meters, 323 meters, and 795 meters. What is the perimeter measured in kilometers? Well, I'm going to add them all together and then I'll change it. So 455 plus 806 plus 423 plus 795. 5 plus 5 is 10, plus 6 plus 3 is 19. carry the 1. 9 plus 1 is 10, plus 5 plus 2 is 7, carry the 1. 4 plus 4 is 8, plus 8 again is 16, plus 1 is 17, plus another 7 is 24. So currently we have 24,000, not 24,000, we have 2,479 meters. That's the perimeter, okay? Boundaries means perimeter. We want to change this to kilometers. So we need times by the ratio, right? The conversion ratio to convert this over. We want meters on bottom. How many meters are in a kilometer? Well, there's 1,000 meters in a kilometer, like that. So we cancel out the meters, and then it's just 2,479 divided by 1,000, like so, which means that we move the decimal back 3 places. So it's just 2.479 kilometers. I hope that you enjoyed these videos. This is, I believe, part 4, and hopefully you've watched all of them, and they will help you on the test. And that's it. Take care.